All right, lesson 8-2, areas in the plane. And this is part of Unit 8, the applications of integrals. So, how do we find the area between a curve and the x-axis? So we've got this curve from A to B, and we say, how do we find the area? Well, it's just the integral from A to B f of x with respect to x. Piece of cake. All right, well, how about between a curve and another curve? Well, now if we had same situation, f of x, and now we have a g of x, and technically we really should say f of x is always greater than or equal to g of x. Well, then it's just integral from a to b, f of x minus g of x. I keep putting my parentheses around this because I think it's just healthy, but I've had other people tell me it's not necessary. So we'll see. I'm going to leave them. All right, so just subtract them. It's right there. So here we go. Let's find the area of the region between secant squared x and sine of x from 0 to pi over 4. Really, really, really nice if you know how to graph things. Stand above the x-axis, I believe. Secant squared goes with cosine, so it's going to take off from 1. Not that it really matters. And sine of x does this sort of thing. And pi over 4, this is pi over 2, so pi over 4 is here. So we have a straightforward area here. What's that area? Okay. Integral 0 pi over 4, top secant squared minus bottom sine of x, tangent of x, derivative of cosine is negative sine, yep, wallet, tangent of pi over 4, 1 plus cosine of pi over 4, root 2 over 2, minus 0 plus root 2 over 2. Zero. Knew I made a mistake, and I have to do that. I have to slow my brain down. 0. I feel like I've done something wrong here. Nope. Tangent and cosine is not 0. 0 for 3. Cosine's 1. So 1 minus 1, cancel. Root 2 minus 2 equals root 2 over 2. No units given, so don't give units back, but this would be square units if we got into that. All righty. Keep going. 2 minus x squared and negative x. 2 minus x squared, negative x. Problem. Where's it hit? Oh no, this is why we've been training and learning to do algebra for so long. I'm gonna move my x squared over there and my 2 over there so that I get 0 equals x squared minus x minus 2. Looks like I can factor it, almost like your evil math teacher planned this. We get x minus 2x plus 1. This is usually the point where somebody says, hey, look, it's over here is negative 1. Since it's negative, it's 1. And over here, it's 2, just like you drew it. Right. So 2, negative 2. I don't need the y values. I really shouldn't write them in. It's just going to cause confusion. Now people freak out. What if we're below the line? What if it doesn't matter? As long as this function is above this function everywhere, we don't have to split it up. Now, if we ended up trying to find area down here, then we'd have to stop, do a second integral, because now we're doing this function minus this function. It's flipped. So integral -1 to 2, top function 2 minus x squared minus bottom function -x minus the bottom function. Can we do some combining? We cannot, so let's just integrate. 2x minus x to the third over 3 plus x squared over 2. -1, 2. Cool. All right, blast it out. 4 minus 8 thirds plus 4 over 2 is 2 minus -2. Notice it goes minus -2. That's how come we don't have to worry about the bottom here. It's going to subtract the negative. It's going to add the area up. So there's no negative, positive thing you have to worry about. Absolute values are gone. It's good stuff. Minus -1/3 plus 1/2. Personally, highly recommend doing this. I'll change colors so you can see me doing it, because why not? All right, 4 plus 2 is 6. 8 minus 1/2. That's 7.5. I'm doing this very strangely without a calculator, and that's fine. -8 thirds minus this -9 is -3. Gets us 4.5, which is cool. No units given. Or if you're in the mood, 9/2. Either one works. It's probably about as complicated as you can expect to see it on the AP exam. They might have a nastier problem just to mess with you, but yeah, that's about it. They will turn it sideways, which we're going to do in a minute. Can't grab paper for some reason. So keep going. Find the area of the region closed by the curve of y equals 2 cosine of x and x squared minus 1. Now, one of the problems people have with this is something you'd see on an AP test, is that they start to think, well, we're in the first quadrant. Who said we're in the first quadrant? There's no direction saying, we're just in the first quadrant. X squared minus 1 is down here. It's going to swing up. And then 2 cosine of x is up here at 2. And it's going to swing down somewhere. Now, I can quite assure you I am always going to be as lazy as possible. This is symmetric, so I'm not going to mess with it if I can help it. I'll just take from 0 to this intersection and double it. However, whenever I do that with students, it freaks them out. So how do I find this intersection? Hey, algebra, like we said before, 2 cosine of x equals x squared minus, that's hideous. So we use our calculator, all right? And we find we get x equals -1.26 542, comma 1.26 542. Which point people say, well, I thought we're only supposed to go to 3 decimal places. And I say, yes, obviously we are, but we're not done with the problem. When we're done with the problem, then go to 2 decimal places. So I will show you what I would have done. But again, this just makes students crazy. So I'm only bringing it up in case you ever see it somewhere. And that would be the top one, 2 cosine of x minus x squared minus 1. But for all of you, go ahead and do this, since it'll make you feel all happy and warm and fuzzy inside. 2 cosine of x minus x squared minus 1. Since we have horribly ugly limits, I would just use a calculator at this point. We get 4.9. 995. Again, no units given. I'm not giving any units back. If I were you, I would try both of these and see that you get the same answer, because you should. All right. Now, let's get complicated. And not, oh no, I'm lost in calculus again. It's much more of, wow, this is a pain in the butt. Yeah, exactly. All right. First quadrant, thank you for telling us that. I know that's square root. And x minus 2, so down 2, it's going to come up and hit somewhere here. Got a problem. We just want first quadrant. So this is a really RTFQ, because most people are thinking, I'll just take the top and subtract the bottom. Well, then you've got this extra area here, which we don't want. We don't want that. We want the blue area. So this point, I believe if we plug in 0, we'd get x equals 2. This point up here, we'll have to go find. Let's do that real quick. Square root of x equals x minus 2. Square both sides. X equals x squared minus 4x. Did you forget that part? Plus 4. 0 equals x squared minus 3x plus 4. I don't know if that works. Looks like I made a mistake. Or more likely, my brain's just shutting off and not working right now. Yep, my brain is definitely shutting off. I know if I plug in 4 here, I get square root of 4 is 2. And if I plug in 4 here, I get 2. So 4, x minus 4 is a factor. Yep. You know, I'd like to say I'd make these mistakes on purpose so that we can all puzzle it out together, but it's your boy. X equals 1 and 4. Now, what's the 1? They don't intersect. Well, technically, this should come out the other side here, and they'd hit again right here at 1, but we don't have a plus minus here, so it doesn't, so we chuck that answer out. So how do we do this? The area is going to equal the integral. We just got square root of x dx from 0 to 2. Because there's my 2, there's my 0. Plus the integral from 2 to 4 of the top one, x square root of x. What a mess. Square root of x minus the bottom one, x minus 2 dx. So that is a way to do it, right? I'm not putting up an answer, and I'll explain why soon, because we're going to do this at least twice more. But let's just start with that. All right. Yeah, I should get out a calculator, bust that out, and see what I get. Yeah, I think we're going to get 10/3 if we do all this work. You know what? Time to stop being lazy. This is x to the 1/2 equals x to the 3/2 over 3/2, so times 2/3. 0 to 2, which is some big, huge, ugly number. That's okay. I think it's all going to cancel out later. So 2 to the 3rd is 8. Square root is 2 root 2. 0 is gone. 2 root 2 times 2/3. Right? Which is 4 root 2 over 3. Okay. And this one we get, yeah, that's what I said, it's all going to cancel out. Same thing, 2/3 x to the 3/2 minus x squared over 2 plus 2x, all from 2 to 4. When I plug 2 in here, I am doing the exact opposite. We're going to subtract all this. It's all going to cancel. So we really got to worry about the 4. Well, and the 2 here and here. Let's put it all together. We get this value here, 4√2/3 minus everything here. Plug in 4, square root of 4 is 2 to 8 16/3 minus 8 plus 8 minus, see ya, plug in 2, 8, 2, 4, yeah, right, 4√2/3, that looks familiar, minus 2 squared is 4/2 is 2 plus 4. Holy cow, what a nightmare. I can see why I wanted to be lazy. By negative 2 plus 4 is 2, then it's minus 2. So we get 16/3 minus 2, but 2 is 6/3. Oh, went off screen, sorry, equals 10/3. So I'm actually glad I did that. It's much of a hash as I made of it. There's a reason. So let me tell you the end of the story now. Right, there's got to be a better way to do that, because look at that mess, all right? And in this case, there's functions out there that kind of, get defined much better with respect to y. For example, what we just did. Now here's the hard part. We just had our feet. And we're looking north. When we do this with respect to y, we come over here, trying to draw the toes. I'm pretty good at drawful. No, I'm not. I'm terrible. Who am I kidding? And we're looking this way. So furthest away is this one. Closest is this one. So it would be, this would be f of y. And this would be g of y. All right. What's furthest away? F of y. So that's why it's on the first one minus the second one. Examples always help. Let's do one. All right. And it's the same problem we just did. It doesn't look like the same problem. Well, let's see if we can make it look like the same problem. Actually, no, it's not the same problem, but it will be soon. All right, so y equals x to the third. First quadrant. Don't need to do the rest, but that's how I draw. And bounded above by y equals square root of x. And below by the y-axis. And the line y equals x minus 2. Where did I get this cube root thing? I must be reading the wrong question. Otherwise, I was reading down here. Oops, because I was down too far. Live and learn. All right, so let's try this again. Hopefully you have enough room. Square root of x, x minus 2. Hey, that looks familiar. All right, so change it. Y squared equals x, x equals y squared. Write it in terms of x. Change it. X equals y plus 2. This is x equals y plus 2. This is x equals y squared. Now, when we turn it sideways, this one's above. So, integral y plus 2 minus y squared with respect to y, and be very, very careful here. What's our limits? I don't know. Remember, this point was 4, 2. This point was 2, 0. Got to think now. We're moving 0 to 2 and 2 to 4. Now we're going to go 0 to 2. 0 to 2. I'm going to do that again, try and help you out. We were on the x-axis, so we said start here and go to this piece, and then we covered that, and then we went from here to here, and we covered that, so it was 0 to 2, x, 2 to 4, x. Now when we turn it sideways, we're going from here to here, which is 0 to 2. Tricky stuff. Do love using the dock for turning things sideways. Could never do that before. All right, no idea what the hell just happened. Y squared over 2 plus 2y minus y to the third over 3, 0 to 2. 2 squared is 4 over 2 is 2 plus 4 minus 8 thirds minus 0, 0, 0. Well, that's nice. Equals 6 minus 8 thirds. 3 times 6 is 18 over 3. Holy cow. 10 thirds. Same answer we got before. I can't overstate how much easier that was for me. All right. Show you one more way to do that, but not right now. Let's take a look at this one. Started doing this one before, did it wrong. So I'm just going first quadrant this time. Oh wait, no, it doesn't say first quadrant. Draw it all. Square root of x plus 2. Inside the parentheses should go right, goes left. So this and this. Oh my lord, that looks horrible. Well, let's just see. X would be the cube root of y if I wrote it backwards. Y squared equals x plus 2. X would equal y squared minus 2, which I don't have to worry about this one over here because that covers the whole curve, because now it's y squared. Turn it sideways. This curve is above all over. All right, cool. Now I just got to find the intersections. Where does x to the third equal square root of x plus 2? This looks tricky. Yeah, I'm going to cheat and just use my calculator. So this is y equals, because I care about the y's, y equal -1. This would have gotten me x's anyway, which is no good. I'd have to plug it back in and see what happens. So y equals -1, and up here y equals 1.793. And I just said how we should use more decimals than that, and here I am not. What can I say? I'm an evil person. So -1, 1.793. The top one, this is confusing, is the y to the 1/3 minus the bottom one, y squared minus 2 dy. Blast it out. Calculator, 4.215. Pretty cool. By the way, even though I wrote this 1.793, when I find the intersection, I store it in my calculator, and then I plug that value in here. So I have a like 8 decimals per piece here. Makes my life a little bit easier. All right, so back to the original one. Not the original, but the one we've done twice now. Okay, let's just do this whole area and then subtract out this little area. So the whole area is the integral from 0 to 4. This point is 4, 2. Of the top one, x to the 1/2 minus the whole bottom one. And hang on, I'm a little confused. I got to think about this a little bit. Oh, we don't want this one. Actually, I'm doing it a different way than what I've done. Actually, in the past, I would subtract off this triangle. This time I'm going to, nope, that's too hard. Let's just do that. Let's do this whole thing, which gives us this area, and then let's subtract off this. Knowing that this point here is 2, 0. So I don't need to do this. I'll just go from 0 to 4. x to the 1/2 dx, and then I will subtract that off, minus 1/2 base times height. Base, 4 to 2 is 2, height is 2. Cool. X to the 3/2, 0 to 4, minus 2. Square root of 4, 2 to the 8. 2/3. So naughty. 2/3. Minus 0, minus 2 equals 16/3 minus 2. 3 over 3 equals 10/3. So, as always in calculus, there's multiple ways to do the problem. I made a pretty much big hash out of this, so I do apologize. But at the same time, I don't worry about it because people should know it's not easy. Everybody gets it wrong, even the teacher. But yeah, you can do it lots of different ways intelligently. Definitely be ready for this. That will pop up on a test in your near future and very likely in the AP. I believe they have a pool of problems that they say, we're going to pick 2 of these 5 problems. Let's make them go to the y-axis. Let's make them do something mildly logistic. Let's make them do, you know, funky little infinite series. This is one of the ones I can throw at you. And it's not too bad. Just change your perspective, above minus below, and make sure you're working with the y values. So that's it. Good luck.